This video will introduce the topics of complex numbers and using factoring to solve quadratic equations. The learning outcomes are to perform operations on complex numbers and to solve quadratic equations using the zero factor and the square root properties. Before talking about these outcomes, you may need to review your skills of simplifying radicals and factoring polynomials. Review videos and blank My Notes are provided. Before doing operations on complex numbers, let's review complex numbers in general. In the number system, we have natural numbers. These are numbers we naturally use for counting, like 1, 2, 3, etc. Whole numbers are the natural numbers plus the number 0. Integers are the whole numbers and their opposites, their negatives. So integers are 0, 1, 2, 3, etc., as well as -1, -2, -3, etc. Rational numbers are numbers that can be written as ratios or fractions. If a number is not rational, we say that that number is irrational. A few examples of irrational numbers will be decimal numbers that have no repeating pattern, the number pi, or the natural number e. All of these numbers are real. We also have non-real numbers that we call imaginary numbers. These numbers have the imaginary unit I attached to them, and the imaginary unit I is defined as the square root of -1. Complex numbers are numbers that involve both the real and the imaginary numbers and are written in the form of a plus bi. Let's talk a little bit about writing complex numbers. Any number we write, such as the number 3, is a complex number, where the imaginary part, b, is equal to 0. So 3 is also 3 plus 0i in complex form. The other special situation would be the pure imaginary number of 4i, which is the complex number of 0 plus 4i. Combining these two numbers, we would have the complex number of 3 plus 4i. One more note I want to mention is what I call the parade of pretty numbers. Let's write some examples of numbers and terms, such as 5xy and 3x the square root of 7. If these numbers were imaginary, I would write 5xyi and 3xi the square root of 7. Notice that we write letters in alphabetical order except when we have the imaginary unit I. We treat I as a radical number, and we write radical numbers at the end, but we write I before the actual radical sign. This is why I call this the parade of pretty numbers. The pretty integer numbers go in the front, variables in the imaginary unit I go in the middle, and the radical number goes at the end. Moving on to simplifying radicals that contain negative numbers. Remember to think of the square root of -49 is the same as the square root of -1 times the square root of 49. Now take the square roots of each and we find that we get I and 7, and we write the result as 7i. So I always say to take the i's out first, then simplify the radical as usual. To add and subtract complex numbers, think of like terms. You can only add and subtract real numbers with other real numbers, and you can only add and subtract imaginary numbers with other imaginary numbers. When multiplying complex numbers, think of doing FOIL. I do FOIL in a different order. My students say I do FLIO, F-L-I-O. So for example, if we have 2 plus I times 3 minus 2i, I would multiply 2 times 3, then I times -2i, then I times 3, and finally 2 times -2i. Using the fact that I squared is -1 to simplify this term, and now I can add like terms, the reals with reals and imaginary with imaginary, so that I can get my final answer. There is one big fact you need to know about dividing complex numbers, and that is that you really do not divide complex numbers. You actually rationalize the denominator of the fraction. For example, if we have 2 over the square root of 6, we need to get rid of the radical sign that is in the denominator, and we do that by rationalizing the denominator. That means we multiply both the numerator and the denominator by the square root of 6. This will give us 2 times the square root of 6 at the top, and at the bottom we will have the square root of 36, which is 6. So we have eliminated the radical sign in the denominator. We just need to simplify our fraction so that we have the square root of 6 at the top and we have 3 at the bottom. So for dividing complex numbers, we will multiply both the numerator and the denominator by the complex conjugate of the denominator. Let's first take a look at conjugates. Conjugates are in the form of a plus b and a minus b. When we multiply these two, we get a squared minus b squared. The complex conjugates are in the form of a plus bi and a minus bi, and when we multiply them, we get a squared minus b squared I squared. Simplifying the I squared, we see that we get a squared plus b squared, since the minus sign and the negative 1 from the I squared will be combined to become positive. So we find that multiplying complex conjugates, we will get a real number and we have no more imaginary parts. Now back to dividing complex numbers. If we have 2 plus I over 3 minus 2i, we would multiply the top and the bottom by 3 plus 2i, the complex conjugate of the denominator. From here, we would use our skills of multiplying complex numbers to complete the problem. Before going to the next learning outcome, please make sure you are able to factor trinomials as well as difference of squares. I have inserted some pages in the blank My Notes about factoring and supplied the videos covering these examples. One method for solving quadratic equations will use our ability to factor quadratic equations. This method uses the zero product property, which states that if a times b equals to 0, then either a or b must equal to 0. So first we will write our quadratic equation in the standard form of ax squared plus bx plus c is equal to 0. Then we need to factor the left side of our equation. Then we set each of the factors equal to 0 and solve for x. Your book refers to this method as the zero factor property, since you are setting the factors equal to 0. Please note that this method will only work if the quadratic equation is equal to 0, and if you find prime factors of the quadratic expression. Sometimes we find quadratic equations that are missing the x term, and we can solve them using a special method, especially if the situation is not the difference of squares, meaning that it cannot be factored. For example, if our quadratic equation is ax squared plus c is equal to 0, we can isolate our variable by subtracting c to both sides and then dividing by a to both sides, and we would have something that looks like x squared is equal to some number. We can then use the square root property to solve this type of problem, which means we take the square root of both sides of the equation. When we take the square root of the number, we need to make sure that we state that the result can be either positive or negative. Notice that solving quadratic equations, the result will either be one real value or two values that can either be real or imaginary. We get one answer when the number that we are square rooting is 0, and we get two answers if the number we are square rooting is not 0. And this concludes this video.